Good morning, good afternoon, good evening. Hello, everyone. My name is James Yi. I'm the Senior AI/ML Partner Solutions Architect at AWS. Yeah, I'm very honored to join this workshop and give you two sessions actually. One is like overview of the distributed training, and also second one will be SageMaker distributed training. There's no clear boundary between these two sessions. I will just mix them together, right? So because when I introduce distributed training, and then naturally I will also talk about how you do the distributed training on the SageMaker. Yeah, so it will be together. So this is the overview for the session. There are three parts. The first part is the general distributed training. As Joe just introduced, I will talk about two different ways for doing the distributed training. One we call the model parallelism to deal with large model, right? And the data parallelism is to handle when you have tons of data, how you can parallelize those calculations. So after that, we will introduce how you can manage your training with SageMaker, how the SageMaker can make your training life a lot easier. So in the end, we also share some tips and tricks or lessons we learned internally. So how you can improve your performance in the future. So let's get started. So yeah, distributed training, right? Before we directly talk about distributed training, maybe we can just overview the history of the large-scale models. Right? Like we all know, machine learning has already been proved itself to be very useful across many different areas. So from the credit risk prediction to anomaly detection, right, to some forecasting recommendation system. We can use it now for generative AI. We can do it for NLP, natural language processing. We can also do the computer vision. So yeah, on the left, you see a picture with a living room. Actually, this one was created with a GAN model, GAN, Generative Adversarial Networks, which has been very popular old times, actually, just a few years ago, actually, 2017. When it comes out, it's kind of jaw-dropping. Everyone talked about it and trying to practice it. But from the picture it created, you can see, and it a little bit messy, right? So you kind of see it's a living room. You see mirrors, some lightnings, and maybe chairs, but you cannot figure it out the exact boundary shapes of these chairs. But it was already fascinating at that moment. But on the right, you see a very nice picture, very neat, clean, right? We see the paintings on the wall, we see the TV and the sofa. And even we take very close, you barely can see it's really a real picture or you're created by the computer. So it was done by the diffusion model in 2022. So we can see the clear difference. So we really see the rise of large-scale models. But in the back end, what actually happened? How we make the breakthrough, right? And first of all, we have to say there are notable algorithm improvements, right? And a couple of years ago, when we talk about machine learning AI, we naturally think, okay, it's going to be some classification and jobs, right? We use maybe algorithm logistic regression, support of vector missions, decision tree, random forest, right? We probably don't hear these kind of terms very often anymore. After that, we have the models the the neural network coming out. We talk about CNN, we talk about like RNN, we talk about LSTM. But like this, after that, like in 2017, transformer architecture was released. Right? So that also really changed a lot. I mean, don't take me wrong. I'm not saying those kind of logistic regression, random forest descent are not useful anymore. No, they're still pretty powerful and still can handle some classic classification problems easily, right? And they have still their space. But this area will really evolve fast, and we have more and more new problems like coming out. Want to like have like sophisticated solution, right? So that's the reason transformer model like become the rising star. So alongside the algorithm improvement, we also see that people use larger data set, larger models, and more computing. So that really leads to significant improvement in the model performance they trained. It turns out like, okay, people just can increase the size of the data and also increase the size of the model and continue use the bit compute. They can get a better and better result and following the power law. There is already ongoing research into this exact scaling laws. Like, okay, what are the boundaries and when and where it will really drop. But for now, it looks like if we can just continue increase the size of the model and the data, we can get a better result. So because of that, over the last 5 years, the size of the model really exploded. We can potentially triple the accuracy of our model simply by just time xing the size of these models, right? To time x the model, you need also time x increase in the data size, and also in the computing cost, and also like computing sizes. And in particular, the increase in the model size is faster than the increase in the GPU size. But the hardware has been increasing throughout the time, but it is been increasing at a lower pace comparing with the size of the model, the data sets. So that really leads to a bottleneck. So where a model is just too large, cannot simply to fit into a single GPU. So meanwhile, like the data set getting larger and larger, right? You cannot easily train your model for all these data on single GPU nodes. Actually, yesterday I just provided a question to ChatGPT. I asked, okay, how you can train your large language model on how much time it's gonna take to train a large language model on the single GPU node? Like ChatGPT's responding is like, okay, so if you train the GPT-2 model, right, like a 1.5 billion parameters, just using one GPU, it takes like a couple of months. So if you use a GPT-3, which 100 billion parameters, gonna take a lot of years. Don't even think about a GPT-4, which have like a trillion parameters. That's gonna take forever, right? So this kind of big data size and also big model size really the pain point currently all data scientists are facing. So how we can solve it? In AWS, we work together with customers, right? Trying to provide the best solution. So that's naturally coming out the distributed training. So, I mean, basically it's just, okay, instead of train your model in just single nodes, we can train a model in different devices, right? From the small scale, like just handful, like GPU nodes, all the way to like 100, even 1,000 of GPUs within just a single SageMaker training job. So let's talk about that in detail. So most customers actually do like two approaches, as Joe mentioned in the very beginning. We have a data parallelism and also the model parallelism. So in the data parallelism, parallel training, the data sets will be split into several shards. Each shard is allocated to a device. Each device will hold a full copy of the model replica and train on the data set shard allocated. So after the back propagation, so on each device, right, and the gradients of the model will be all reduced so that the model parameters on different devices can stay synchronized. And yeah, that's about like the data parallelism. We also have the model parallelism. That's the method we handle the large model. And there are generally two types of model parallelism. One is tensor parallelism. And for the tensor parallelism is to parallelize the computation within the operation, like such as a matrix multiplication. We also call the tensor parallelism as an intro layer, since it's parallelize the computation within each layer. And we also have the pipeline parallelism. So in that sense, we parallelize the computation between layers. So in that sense, we also call it interlayer parallelism. So at AWS, we rapidly invent solutions that meet customers' needs. So in 2021, AWS launched our Amazon EC2 TRN1 instances. It is powered by AWS Trainium accelerators, and which are purposely built for the high performance deep learning training, while it can offer you up to 50% cost to train savings over comparable GPU-based instances. So in this picture, you can see there are 8 accelerators that are populated. All of these Trainium accelerators in a single instance are connected to each other. So the data parallelism distributes data across multiple devices and copies the model per device. So while we do the model parallelism, it will partition the model across multiple devices on our TRN1 instance. So it really helps overcome issues that arise when training deep learning models that are typically very large in size. Okay, let's take a close look, data parallel and also model parallel one by one. So I would like to let you think, okay, data parallel, like I would like to think we really deal with a massive data, like 100 gigabytes, terabytes. So historically, there are 2 popular approaches. One is a parameter server, example like the TensorFlow parameter server strategy. And we also have MPI or reduce, so like the Horovod PyTorch distributed data parallel. So what are they, right? So what does that mean? So for the parameter server, actually, like you need a parameter server, which kind of sitting in the middle, right? Running as your primary leader nodes. And this leader node is communicating with all of these other worker nodes. It is looking at the gradient updating on each of these workers for aggregation. So after gradient aggregation and the weights updates, this server will broadcast parameters to all workers. So there is certain advantage, right, for this. This really can do the data parallel. But with this paradigm, the bandwidth required at the server increase as we have more workers or more parameters are added. So there's a second approach, R-reduce. So in R-reduce, instead of having just a single server and to perform the heavy aggregation, we actually can share the workloads. We can distribute the aggregation tasks to all workers. So each worker sends a subset of the parameters to all other workers, right? Like the parameter server 1 send A1, A2. Parameter server 2 here in the picture sending the parameter B1, B2. So each worker perform aggregation on a subset of parameters. And after the aggregation, it broadcasts to all other workers. In that sense, the R-reduce will result in the lower bandwidth requirement at workers, since workers exchange only a subset of parameters. And there is also special ring R-reduce like the Horovod, but I mean, the methodology in the background is similar to this one. So I'm not going to dive deep into the detail for the Horovod. So at AWS, we have our custom communications protocol that can enable optimized inter-GPU communication between nodes on AWS. So this is how you can easily achieve state-of-art performance for the large-scale distributed training on the cloud. You can easily get like 20 to 40 faster in training time and cheaper in cost. So how do we do that? And when you launch a training job with SageMaker Data Parallel, actually the CPUs on your GPU instances become the parameter servers. So we introduced a new technology called a balanced fusion buffer to make the optimal use of the bandwidth. So a part of the GPU will work as the fusion power. So it will hold the gradients until they hit a certain threshold. So after that, we will copy the fusion buffer to CPU memory and shard it into multiple parts for each node in our cluster. And also then send to them to like the certain parts to the certain server. So in that way, we can this balance the data being sent also received from each parameter server, ensuring the bandwidth is efficiently utilized and addressing the primary challenge with traditional parameter servers. And yeah. So we have a publication which is available online. And so like if you're really interested, feel free to like read it. Yeah. So that's the data parallel, how we do it on AWS on SageMaker. So I want to check is any question on that?
Yeah.
No, I can just okay.
There was one question which was answered. Asking Irving White.
Would you like to know the link?
Yes, you already provided.
So you can search the paper title.
Oh, okay. Yeah, I will just stop on this slide so they can.
Somebody posted the link.
Yeah, thank you.
Okay. Okay.
Thank you, Jonathan.
Okay. So then we talk about the model parallel. So like similar to model parallel, right? So if we talk about a model parallel, I would like you to think we are handling a massive model, right? Really a big model cannot be put into a single instance. on Avalon SageMaker, you really can, again, there are quite a few benefits. So it automatically and efficiently partition your model, right? So you get an automated model partitioning. And after that, it will set up an efficient pipeline that can maximize the GPU utilization. And all of this actually take place in a fully managed environment in SageMaker. So we handle the infrastructure backend, so you don't need to worry about that anymore. And also, it's integrated with the most popular frameworks, like the TensorFlow and the PyTorch. So let's see how this works. So when you create a training job on SageMaker, so SageMaker will analyze the model graph. Right? It will analyze the graph structure, and it will count the size of the trainable weight, and also take a look at the size of the exchange of tensors all by SageMaker debugger. And after that, the SageMaker will partition the graph in a way that can really balance the compute and also minimize the communication. That's really important, because if we have many kind of inter-GPU communication, and it's really slowing down the training. So that's the thing we want to minimize. And in the end, it will set up efficient pipeline to execute mini batches on different devices. So for the pipeline model parallelism, SageMaker split each batch into number of micro batches, which are fed into the training pipeline sequentially. And all of this also follow execution schedule defined by the library runtime. So this strategy really minimizes the amount of the time GPUs are idle, right? Are waiting for the data, and make the running more efficiently. So this also kind of remind me of yesterday's topics, right? We can also use some on SageMaker. We also have some monitoring tools, right? And also you can also use the third party, our partners tools like Wisdom Bias, right, to monitor the performance. So monitor how your hardware better use. Later on, I will show a detail for the monitoring. So again, this is the paper. So here is the paper we published talking about Amazon SageMaker model parallelism. So we have a dedicated team and researchers working in that area. And this figure illustrates an example of the execution schedule for the interleaved pipeline over 2 GPUs. So in this figure, yeah, we have GPU 0 and GPU 1, right? And F0 means the forward pass for the micro batch 0. And the B1 represents the backward pass for the micro batch number 1. So you can see how we run them with the time, right? And updates represent the optimizer update of the parameter. So GPU 0 always prioritize the backward passes whenever possible. For example, here, cannot see my mouse. But anyway, so B like for instance, it will execute B0 before F2. Yeah, because like after the GPU 0 finishes the F1 job, and then like it want to finish the back pass for number 0 first, right? So in that sense, it can clearing the memory using for the activation earlier, right? So release the memory and then make it like to shorten the idle time. And we also have like the tensor parallelism, right? So we can use a tensor parallel, like really short tensors layers, right, of your model across GPUs. It can handles the learning loop and including forward and also backward pass. And yeah, here is our blog post published in AWS Machine Learning blog, and you can train a really big model, right? 175 billion parameter NLP models with a model parallel additions and Hugging Face of Avalon SageMaker. So if you are also in NLP domain and you have heard of Hugging Face before, and yeah, please read this article. And they also provided an example notebook, so you can also test in your own AWS environment. And like to provide like things like that's all the methodology what I shared, right? And I know like people sometimes when you have like only the knowledge, right, the concept, how you can get started, right? So like don't worry, here online we provide a lot of SageMaker examples. So if you go to the GitHub, so you can please visit Amazon SageMaker examples training and the category distributed training. There are many examples for data parallel, for pipeline parallel, and the tensor parallel. So you don't have to like start from scratch, right? So yep, I'll stop at this slide maybe for like 10 more seconds, so you can write it down. Yeah, of course. And after my presentation, we will also have like 2 sessions. One like for the data parallel lab, and also another is a model parallel lab. So you can also try even today. Right? I think later on we can also share our workshop examples, right, online, so you can also use in the future. Well, here we here is a good successful use case that we have, and in this use case we actually use Amazon as our customer. Right? So because the one I just introduced, like the SageMaker, data parallel, model parallel, and we also welcoming the users who used to use like the distributed training method by other provided by other kind of like your method, right? So in this blog post, actually, we recently make the PyTorch Lightning and also PyTorch data distributed data parallel also can can easily integrate with Amazon SageMaker, because previously when PyTorch developers, they want to migrate, right? There are some old datas, like using the PyTorch Lightning, using PyTorch DDP, they don't know how to do. But right now, it's it's integrated with Amazon SageMaker. With just change one line of code, it can easily plug in with SageMaker distributed data parallel backend. And this is an example done by Amazon's Amazon team, right? So we worked with Amazon Search to enable large-scale training on Amazon Search. So when you are looking for a new product on Amazon.com, we actually train a model in the backend to provide better recommendations for the products that you leverage. So, I mean, the scientists at Amazon Search used to use PyTorch Lightning. They still want to keep their code, right? So they don't, and in particular, like every scientist, they also like to run the large scale jobs and getting results quickly and efficiently, right? They also say, hey, since they're Amazon and AWS also have a lot of new features, we have our powerful GPUs. Is any way we can also, without change a lot of their codes, they can also easily use like SageMaker or Data Parallel, like our training. Now you can easily do that. So if from the table shown here, with increase of number of instances from 1 to 8, you can easily get an improvement of your training time by almost like 7.3 times. So that's really save a lot of training costs and also decrease your training time. Feel free to take a look. And most recently, we also developed a new feature. We call it sharded data parallelism in SageMaker model parallel library. Right. From the name, you probably can also see really we kind of mix the data parallelism and the model parallelism together. Right. So you divide the GPUs in the cluster into 2 groups. One is partition groups, right? 0, 1, 2, right? And for the partition groups, you really partition models with each group. And we also have a replication group, right? So that for the GPUs in the replication group, we'll hold the same model copy, but different data shards. In that sense, we can effectively control the communication overhead. So this method it's really to dealing with the gigantic models, right? And it has been tested. We really can save almost 40% speed up compared to the deep speed ZR03 and like almost 40% speed up compared with PyTorch, the full sharded data parallel. There are also memory reduction strategies. They reduce the memory footprint within GPU itself. You can then increase batch size to increase the overall throughput of the model. There are like many different ways. So I'm not gonna talk them one by one, but you get the concept, right? And one thing I will particularly also mention is the privacy-preserving federated learning. So, like the previous distributed training approaches really focus on like larger data set, larger model, how you can improve the training time. But for some use cases, right, when we talk about federated learning, like we sometimes we have the data security. Certain data cannot be moved to like certain area, and how we can, train the same model but in different areas with different data set. Right? So that's that's the reason why we need a federated learning. So I'm not going to dive deep in the details since we have a specific session by Jill in the afternoon. So, but these are all related, right? Federated learning is all kind of one kind of distributed training. Okay, so that's enough for like the data and the model parallelism. Now, like I want to point out like the features, like what benefit you really can get, how you train your models on Amazon SageMaker in general. So when we run SageMaker training through, we always like use the ephemeral training clusters. Like when I submit a training job, SageMaker will just spin up a cluster based on the cluster configurations that I choose, right? It will load the training code from the ECR, Amazon Elastic Container Registry, and also the loaded data from S3, and then start the training. Throughout the training, it will output the logs, metrics to the CloudWatch, or maybe Waze and Miles, right? And also it synchronized my model checkpoints over to S3. And at the end of the job, it was spin down the cluster. So, in one of the benefits in this configuration, if in case the job fails for whatever reason, right, in the middle of the night, right, the cluster will automatically spin down, and then you stop paying for the job because you always like have the pay-as-you-go methodology on AWS. You don't have to worry like you are kind of just opening your cluster, like very expensive cluster, right, with like many GPUs on it, like for nothing, right? It will automatically spin down the cluster for you. Of course, if you've written your code to be resilient, right? You can do that. You can like resume from the checkpoint. You can set the training job to automatically restart without manual intervention, and also do that. And also there are different ways you can train your own deep learning model. So you can, SageMaker provides like 70 plus AWS managed deep learning containers. Those container images with popular deep learning frameworks like listed in the bottom, right? MXNet, PyTorch, TensorFlow, right, and Ray. So, so for training your own deep learning model in SageMaker, you can use SageMaker Python SDK that will provide the framework estimator, right? We have an example here. So you just bring the custom Python packages in the requirements, the txt file, right? And then you just define like, okay, which Python job you will run, and what's the framework version, right? Here is like like in this example, it used PyTorch and like 1.8 version, and yeah, like how many instances you need and what's the type of instance. Yeah, you just give these kind of details in the estimator. So you don't have to like right, like you don't have to be like you're facing like hundreds of lines, right? And then switch and back and forth and see how I can change my parameters for training, right? You can just have a kind of centralized estimator and then control these parameters. Then the estimator will just communicate for you. And of course, you can also bring your own Docker containers. Like if you don't want to, or like all these available deep learning models are not are not for you, right? You can always bring your own Docker containers. So, and like the SageMaker training toolkit can be easily added to any Docker container, make it compatible with SageMaker for training models, right? You can just simply run pip install SageMaker training. So, and so that you can in that case, you will use AWS SDK APIs, such as create training job, right, to train your models. So here is an example of the Docker file, right? So you use your specific container, and then yeah, you can do that. Yeah, you can set it up. And we have our development documentation to guide you how you can do this. So I don't have the link here, but if someone can help me to just put in the link in the note, that'd be helpful. If even you probably can just search bring your own Docker containers SageMaker. I think you will find it. And there are also topics that we want to understand for distributed training, right? A single mode, and also multi-node. Single node means you have one is EC2 instance and also one Docker container. We can also have multiple virtual servers and also multiple EC2 instances. In that case, we can have one master image from ECR to pass the code and the data to the nodes. And you actually can also do the distributed model training on a single node, because you can have multiple vCPUs on a single node, right? Each vCPU can take a different versions of your model and training with a different set of data. One of those frameworks that helps you to do that is HorrorVault. HorrorVault is a very common way of distributing your TensorFlow models on a single host. So in this example, your instance count is 1, but you can set up your processes per node as 2, right? So HorrorVault helps you to run multiple processes on a single node. And I'm also stop here and check. All right, let's continue. For the next session, I want to share the tips and tricks, lessons, right, we learned from our experience, right? So it can really help you to improve your performance. So when you thinking about using the SageMaker training and the distributed training on SageMaker on AWS, and one thing I want to one question you need to think about in the beginning, right, is pick the right data option for the SageMaker training. Right? Where is your data, and what's the data format? How big of your data size, right? So on SageMaker, the SageMaker training naturally integrate with 3 AWS managed storage services. S3, right? The famous S3, Amazon Simple Storage Service. It is an object storage service that can offer industry-leading scalability, data availability, security, and also performance. And also we have Amazon FSx for Lust. It is a fully managed shared storage with the scalability and the performance of the popular Lust file system. And it is usually linked to existing S3 buckets. We also have Amazon Elastic File System, EFS. It is a general purpose, scalable, and also highly available shared file system. Yeah, you have different options, right? So the diagram on the left shows the 5 training jobs. Each of them configured with a different data, either data source or maybe the input mode combinations. So the flow chart on the right, provides some guidelines to help you how you can get started, right? So first of all, you should ask your question. Where is your current data set is stored, right? Whether it's on EFS already or on S3, right? And then if on S3, then you need to check how big of your data set, and right, and then if it's at different range, and then you have different options. So yeah, this kind of a diagram give you some idea. Okay, so what you need to get started, right, for the data. And then we need to think about, okay, what kind of a computing resource we need for the training, right? First of all, data, and then like the computing resource. So we have many different types of EC2 instances for distributed training. Most popular, here are listed the most popular ones, and like the G4DN all the way to the P4DN, right? Some is ideal for like the small to medium sized models, and some more for the larger sized models. And they have their own different key features. Of course, the price are also different, right? So you can, yeah. And also, we also recently also launched a couple of new instances, right? Habana, Gaudi, Trainian, G5, G4DE, and you can also check their technical details online. They're all very powerful, and they're dedicated for the deep learning training. So now you have many different options for the instance. Then how you can make the decision, right? Let's have a decision tree for that, right? So the first question about the instance option you need to think about is which machine learning domain your project belong to, right? If your job is if you're dealing with time series data, numerical data, right, and you don't need acceleration, probably CPU instance is a good option for you. Well, GPU may speed up a little bit, but like CPU should be good enough to handle this type of work. Meanwhile, then you can save the training cost. But if you are dealing with the NLP, the computer vision, the recommendation with using tons of data, right, with many columns, right, and maybe mixed with numerical and text data. Well, in that sense, you need to think about you're using distributed training and use this kind of most advanced EC2 instances. So then you need to ask, okay, and whether you need multiple GPUs and whether you need to do training, right? By asking yourself these questions, that will lead you the different options of these GPU instances. So you don't have to always say, hey, I want the most advanced, like the GPU, the CPUs. Well, of course you can use it, but it may not speed up much for your training. And talking about the training, and then we also need thinking about the inferencing, because inferencing is also very important, right? So after training, how you can deploy your model and also shorten the inferencing time, right? Then it make the customer experience a lot better. So on AWS, we also have different options for machine learning inferencing. One is INF1 instance, which is powered by our inferential accelerators. So, and we also have the G4DN for the customers who are interested in staying with the NVIDIA ecosystem due to the model framework or operator support. So, oh, by the way, for the inferential, it currently support the PyTorch and the TensorFlow. Right? So same thing, let's build up the decision tree for machine learning inference, right? Thinking about your domain, right? Which domain it belongs to. And then after that, you ask yourself, like you check whether your framework or model supported by INF1. Like if you are using PyTorch and TensorFlow, it's supported, right? I highly recommend you use INF1. It can save your training cost. So yeah, then you after you decide, okay, I use your INF1, then you think, okay, whether you need your very powerful multiple accelerators or not, right? We have also different options, all the way from the INF1 X large to your 24 X large. So you can find all these technical details for different types of inference in our website. Oh, another option actually you have is using spot instances, right? So because it can save you the training cost up to 90%. That's really our cheapest spot instance, is the cheapest instances that it lets offer. So you can simply set it up in the SageMaker estimator. You just turn on the use spot instance options. So we also have the blog post kind of telling how you can reduce up to 60% price on using machine learning P3 and machine learning P2 instances. Yeah. That's it. And yeah, another thing I want to point out here would be the Amazon SageMaker training compiler. So because state-of-the-art deep learning models consist of complex multi-layered neural networks with billions of parameters that can take the thousands of GPU hours to train. Optimizing such models on training infrastructure really require extensive knowledge, both in deep learning and also in system engineering. It's not an easy work. So SageMaker training compiler is a capability of SageMaker that can make these hard to implement optimizations to reduce training time on GPU instances. This compiler optimizes over 100 deep learning models to accelerate training by more efficiently use SageMaker machine learning GPU instances. You can accelerate your training time up to 50%. So please, when you run your model, please check and whether your model has been included in the supported models, right? And you can immediately earn the benefits. And also don't worry about the code, right? This is an example. You really just change add 2 lines of code, right? Import the training compiler config, and then add it into the Hugging Face estimator. That's it. Yeah. And this is the thing I actually mentioned before. Is okay. So you made your choice for the data, like the data storage, and then you made your decision for the data, which instance you use for training and which instances for the inferencing, and okay, you also consider the training compiler, and you click the button, submit your training jobs, and then what's the next, right? You want to monitor your job performance. You want to analyze how's your training doing. Right? So you actually can use SageMaker Debugger. SageMaker Debugger will generate the profiler report for you, and and it can provide you the training job summary, the framework metric summary, the overview of your CPU, GPU operators. As a result, you can detect whether a model is overfitting or overtraining, right? Whether a gradient are getting too large or too small, whether GPU resources are underutilized, and also any other kind of bottlenecks during the training. And it's very powerful and helpful. Please go check it. And another thing I want to point here is you actually can develop for SageMaker training with a local mode. Right? So you can just use like your local computer, and then start to develop your code for SageMaker G3 training. And also, you just point to the PyTorch. You just point to the local GPU, right? And also using the local session, and it will train locally for testing, right? After that, then after your testing and after you create your script, your nodes, and then you can switch from local to online to the cloud. So it's also recommended path for you to develop your script and models. Yeah. There are here we, as I said, like at AWS, we fastly develop to meet the customer's needs. And like each week, we have quite a few blog posts published on actually different channels. We have our AWS machine learning blog post. We also have the blog post for other category, right? Even for specific domain, like vertical, right? Media and energy. So basically, we provide you a lot of different resources to help you get started. And here I only listed just a few links, right? Helpful links. And the first one is our quarterly machine learning trend for the Q4 of 2022, right? And there are also two blog posts listed here. One is how you can use distributed fine-tuning of a BERT model for question and answering tasks using Hugging Face on SageMaker. And the last one is also very new, is how you can scaling large language model training with TRN1 ultra clusters. So these are, as I said, this is a few examples, and we have many, many different resources for you to get started. And that's the last slide I have. So I'm gonna stop here, and also let's check if any questions. Maybe if you don't have direct questions, maybe you have any, let's say, topics you want to discuss. Welcome. Yeah, this is the time.
Will we get a copy of this slide?
Oh yeah, we definitely will provide that after the workshop. Yeah. So yeah, we will keep you updated.
So currently, what are the use cases from AWS point of view for distributed training?
I have to say, great question, right? Simon has yesterday. Yeah. Starting from the end of last year, beginning of this year, right, we really see the trend for the generative AI. So for generative AI, you're handling really large model. Right now, we call it foundation models. Right? So It's at least billions parameters, trillion parameters. So some of the models, you probably can just directly use it for your use case, right? Zero shot training. And some probably not, right? You have to do the transfer learning. You on top of this kind of foundation model, you have to also train on your specific data set. In that sense, we definitely need the distributed training to help you, right? Because those are all like big model. Yeah. So that's the space. I think that's the future.
So usually it's a NLP or a
Yeah.
CV computer vision models.
Yeah, because like they are the algorithm improve, right? We have to like hardware side, like framework side, we have to catch up. Like for example, like a diffusion model, right? You can like text to image, you can even text to like videos, and all of this like consume a lot of computing like your powers. So how we can manage our like our workflow optimize more efficiently? That's so the
So on AWS, how can we quickly access some of those larger models? Where?
Yeah, you like one direction, one way is on SageMaker we have like Jumpstart. We also host like quite a few foundation models. Some from Alexa, some from like our partners, like Hugging Face, like a Cohere, and the Lab 21, right? And yeah, they're all already available on SageMaker Jumpstart. So you don't have to start from from scratch. And also a good thing for the Jumpstart is if you think, hey, you can just quickly check the model performance, right? You don't have to write any line of code in the Jumpstart. You can just click the button, right? Just like you shop on Amazon.com. You just take a look at the list of your NLP models and say, hey, maybe a Cohere median model is good for me, right? You just click the button, it will immediately spin up like your inference for you, and then you can just test in your own AWS environment. And then then you can make a decision, right? You don't have to write any code, just test it. And maybe after that you think, hey, one of the models is your option, right? You want to like further improve the accuracy for your specific use case, and then you just on top of that use our training, use distributed training to further train your model on your data set. So you have the option.
So we still have 10 more minutes.
Yeah, here in AWS, it may be a couple of more. Yeah. We really like since this is a part enablement workshop, right? So we really want to build like the ecosystem for our users together with partners, not just AWS. For example, this workshop, we invited like multiple partners together, right? SageMaker is one of the options, and you have other options, right? And also SageMaker is also like compatible with like, for example, PyTorch Lightning, like the PyTorch distributed data parallel, right? So you can easily migrate your data set, your models to AWS. And we have our foundation model partners, like Hugging Face, like the Cohere. Yeah. So that's the purpose why we have this workshop, right? So let you know what you have, right? And then we can together, you as a partner, right? We can together build more like a sophisticated, better solution for our customers.
So about the Hugging Face, what are the foundation models available on AWS now? Because now NLP is a trend, right?
Yeah, they are doing a lot, right? From the BERT, basic BERT model to like the GPT-2 and the GPTJ also available, and they also are working on a few more models. So there are more coming out. That I can say. So be patient.
So is it generative AI stuff?
Yeah,
Yes?
of course. Even like a ChatGPT style. Yeah.
Oh, wonderful, wonderful.
So maybe,
Now we have 10 minutes.
yeah, maybe we can just finish 10 minutes earlier and then
Okay.
give them more time to break.
Yeah, so the break time is until 11:15. So let's come back on 11:15 for hands-on lab.
Okay, yeah. That's okay. I'm gonna stop here, and then like please come back on 11:15 so we can start our hands-on lab. Thank you.